Just when you think the AI landscape is, set in stone,
Right.
dominated by these huge corporate players, an open source model just drops. It's called DeepSeek V3.2.
And the claims are pretty staggering.
It's saying it can outperform GPT-5 and Gemini 3 in really critical areas like reasoning and math. This isn't just an update.
Now, this feels like a real shift.
Welcome to the deep dive. The pace of AI right now can feel, overwhelming.
Yeah, it's a lot to keep up with.
Our job is to give you the shortcut. We've spent our time digging through the sources on DeepSeek V3.2.
And our mission today is pretty straightforward. We're going to demystify the core tech here. We're talking mixture of experts and sparse attention.
We need to unpack the 3 different versions of this model.
And most importantly, figure out if this thing really delivers on that promise.
Yeah.
Saving you money without, sacrificing actual intelligence.
Okay, let's start with that. The core architecture. Why is this such a game changer? For years, the models we've used, the standard GPTs, they were all dense models.
And that's the key problem right there. Dense just means inefficient.
How so?
A dense model is like a single massive brain. Every single neuron, every part of that network has to fire up for every single query.
Even for a simple question.
Yeah, you're using the whole brain just to answer, what's the weather like? It's just incredibly wasteful.
So if that's the old, inefficient way, what's DeepSeek's big fix?
The fix is MoE, mixture of experts.
Okay.
Instead of one giant brain, think of it like a team of specialized AI experts. MoE just activates the specific network parts it needs for efficiency.
So it's like having a team, not one overworked assistant.
Exactly. Imagine a librarian who has to read every single book in the library for every question.
That's the old way.
Right. MoE is like having a team of experts,
Mm-hmm.
a math genius, a coding wizard, a history buff. And when a question comes in, only the relevant expert wakes up to answer it.
And the scale of this is pretty massive, right?
It's huge.
Yeah.
The total brain power is 685 billion parameters. But for any given word it generates, it only uses a tiny fraction of that.
And that's the key. That solves the 2 biggest problems in AI right now.
Speed and cost.
You get answers faster, and you need less computing power to do it.
Why is MoE a fundamentally better architecture right now?
Well, it's faster and cheaper because it uses less computing power for every query.
That's the core of it.
Okay, so it's easy to get a bit overwhelmed when a new model family drops. And DeepSeek isn't just one bot.
No, it's a family of 3. And it's really crucial to know which one to use for what task.
So let's break them down.
First up, you've got the main one, DeepSeek V3.2. This is your daily driver.
Generalist.
Yeah, your go-to. It's balanced, it's fast, it's smart, it handles all the standard stuff, coding, writing.
And it can connect to the internet, use external tools.
Yep. It can check stock prices, pull weather data,
Huh.
browse the web. I was using it to plan a trip and debug some simple Python, and it just felt snappier.
Okay, so that's the daily driver. What's the second one, the one all the researchers are talking about?
That's DeepSeek V3.2 Speciale. The genius.
The genius.
This one, it locks the door to focus. It does not look at the internet. It doesn't use any tools.
So it's just relying on its own internal knowledge. How does that give it an edge?
It generates something they call thinking tokens.
Yeah.
It's like it talks silently to itself, checking its own logic step by step before it gives you an answer.
So it's best for things that require pure, structured reasoning.
Exactly. Hard math problems, complex logic riddles, physics. That's its domain.
And the third one, the X.
DeepSeek V3.2-X6. That one is really just for researchers at the moment. It's testing the raw tech. You should probably stick to the first 2.
Which of these versions should our listener use 90% of the time?
The balanced main V3.2 is the general purpose daily driver for daily tasks.
Got it. Okay, this brings us to the benchmarks. And this is where it gets kind of shocking. Can an open, free model really beat the giants?
The numbers, I mean, they speak for themselves.
Mm-hmm.
In math, on the AM 2025 test, which is incredibly difficult, DeepSeek scored a 93.1% pass at 1.
Let's define that.
Yeah.
Pass at 1 means what exactly?
It means it gets the right answer on the very first try.
So no guessing, just immediate high confidence accuracy.
Exactly. And that 93.1%, that beats GPT-5 high, which was around 91%.
Wow.
Then in reasoning, think math Olympiad level, it's hitting gold medal performance. It's matching Gemini 3.0 Pro.
Matching the best in the world. And it's open source.
And for coding, on the SWE bench, it solved over 2,500 issues, which beats Claude 4.5 Sonnet. So it's not just a one-trick pony.
And that amazing performance on logic puzzles and math, that really comes back to the special versions thinking advantage, right?
It really does. Most bots just rush to an answer. Special pauses to verify.
We see that with that classic riddle, right?
Yeah.
If one wet shirt takes an hour to dry.
Yeah, how long for 3 shirts? A normal bot might just multiply and say 3 hours.
But special.
Special reasons it through, understands they dry in parallel, and correctly says 1 hour.
Whoa. Imagine applying that verification ability to scale enterprise-level coding projects.
That's the thing. It's not just about riddles. It's about catching bugs before they happen.
How exactly does the special version achieve such reliable results on hard math?
It pauses to verify its own logic, checking each step quietly before giving the final answer.
Okay, so that efficiency brings us right to the money part.
The part everyone's waiting for.
For anyone paying API costs, this is huge. Let's talk about DSA, or DeepSeek Sparse Attention.
DSA is really the secret sauce that makes all this cost saving possible. It's all about how the model reads the information you give it.
So with the old way, if I gave a model, say, a 1,000-page document,
It had to read all 1,000 pages every single time.
that's dense attention.
Exactly. Just massive wasted effort. DSA is like giving that 1,000-page book a really smart index.
So instead of reading the whole book, it just jumps to the relevant pages.
It only reads what it needs. And the cost difference it's just staggering.
Let's get into the specifics.
Okay, so the cache miss, that's the first time you read a document, is about 20 cents per million tokens.
Which is already pretty cheap.
It is. But the cache hit, when you ask a question about that same document again, the price drops to about 2.8 cents per million tokens.
That's a 90% drop.
In a lot of cases, it's 10 to 30 times cheaper than models that don't have this.
So if you're building an app that queries the same legal documents or internal wiki over and over, your bill just plummets.
It changes the entire economic model for those kinds of apps. I still wrestle with how quickly API costs can spiral when you're querying large knowledge bases. This cache hit model is the cost break we needed.
For a developer reading the same long documents, how significant is the cache and price difference?
The cache hit feature can effectively drop the API bill by 90%, making large-scale processing affordable.
It's cheap, it's fast, it's smart. So what's the catch? Let's talk reality. Can you actually run this thing yourself?
The MIT license is great for privacy. Your data stays in-house. But there's a serious hardware reality check. The full model weights are nearly 700 gigabytes.
So you can't run this on a MacBook Pro.
No, not even close. You need a dedicated server with massive VRAM. We're talking something like 8 NVIDIA H100 or A100 GPUs.
Which is tens of thousands of dollars.
At least. Just for the hardware.
So for an individual developer or small startup, what's the realistic path to actually using this?
You've got a couple options. The easiest, by far, is just to use their API. It's cheap, and they handle all the hardware complexity.
Okay, what's the second option?
You wait. The open source community will almost certainly create smaller, distilled versions. Like a 7 billion parameter version that captures most of the intelligence but can actually run on high-end consumer hardware.
And for the bigger companies that do have that kind of server farm,
They need to use specialized software. Tools like VLLM or SGLang are built specifically to run these sparse MoE models efficiently.
what's the most realistic path for an individual to use this powerful model today?
The easiest way is using their cheap API or waiting for smaller, distilled versions to release.
Makes sense. Okay, let's pivot to using it. If we have these two distinct versions, the daily driver and the logic engine, we can't talk to them the same way, can we?
No, absolutely not. The way you prompt them has to be different.
So for the main V3.2, the daily driver, what's the strategy?
You use it for quick, standard tasks where you need clean output fast. Ask it for a React component for a pricing table. Specify the styling, Tailwind CSS, 3 columns.
And it just spits out the code?
Clean code immediately. It's built for that.
And for the special version, the reasoning expert,
There, you have to be precise. Define the rules clearly. It's more like giving it a formal problem statement. Use it for a complex geometry proof where accuracy is everything.
so the switch is quick email summary, use the main, debugging a really stubborn logic error in your code.
You use special. You match the tool to the task.
For the special version, do I still need to think step by step?
No, special does that automatically, but you must define the rules and constraints clearly.
So let's wrap this all up. What is the single biggest idea you should walk away with?
I think the big idea is that open source AI is officially no longer second best. DeepSeek proves that with MoE and Sparse Attention, Open models can match or even beat the performance of the biggest closed platforms.
And the final takeaway for me is twofold. The special version gives an reasoning power that's on par with GPT-5 or Gemini 3, while the main version gives developers a cost structure that could honestly revolutionize how we build AI apps. The gap between open and closed has basically vanished.
The performance ceiling got raised, but the cost floor just dropped through the basement. That's the tectonic shift.
We really recommend you go and test that thinking mode on the special model yourself. Give it a tough logic puzzle.
See how it works. And here's a thought to leave you with.
Yeah.
If an open source model under a free MIT license can do all this today, what happens to the economics of those expensive closed source AI platforms next?
What does the future of competition look like now? A great question to think on.
It is.
Thank you for sharing your sources with us and letting us take this deep dive. We'll catch you next time.